Here we are creating our first machine learning project in Python by step and step. And how do we get started? So let's get started by a Google search, and then we'll find out what's there for us in Google. So here is your first machine learning project in Python step by step. Let's open it and let's get started. So beginners needs a small end-to-end project. That's correct. We just want to do a small project and machine learning, and so installing Python, loading the dataset, summarizing the dataset, visualizing the datasets, evaluating some algorithms, and making some predictions. So that's what we're going to do, and let's do it. So install SciPy and other libraries. So I've installed Anaconda, as it says here, and my installation process is on the go. So here it is. It's asking me to install Visual Studio. So I'll continue and close. Move to trash, I guess, because I don't need it anymore. Now, as I have installed Anaconda and Visual Studio Code, so the related libraries of Python which are required in machine learning are automatically installed with Anaconda. Now let's get started with terminal, and the first line first, Python. Let's get started. Okay, we have Python 3.7 as it says. Okay, so now we are following the steps: import sys, print, Python, and colon, braces, format, system dot version. Okay, it says Python 3.7, June 28, 2018. And now let's import SciPy and check out the version of SciPy as well by doing print SciPy colon braces dot format SciPy dot underscore version underscore underscore, and let's close the braces, hit enter. SciPy 1.1.0, and we are ready to go. Now let's import NumPy. NumPy is another library using machine learning, and let's print the version of NumPy. So I misspelled it there. It's NumPy. Okay. So colon braces, then I forgot the quotation mark there. Dot format NumPy dot underscore version underscore underscore, and close the braces. Okay, it says invalid syntax. Oh, I see. I missed a quotation mark, single quotation mark there. So I'll again have to print braces, brackets, NumPy, quotation mark, NumPy, colon, then braces, another quotation, dot format, NumPy, underscore underscore, version, underscore underscore, and let's close the bracket. Okay, it says 1.15.1. NumPy is good. Now let's check the matplotlib. So it's plotting library, and we similarly print the version of matplotlib. Now, did I again forget the quotation mark? No, I shouldn't forget it. Dot underscore underscore version. So it's 2.2.3. Now let's check the pandas. So I've heard a lot about pandas. Now finally I got a chance to work with pandas. So here we are, pandas dot format pandas underscore. Okay, pandas dot underscore version underscore underscore. Let's close it. Okay, it's pandas 0.23.4. Now import sklearn, and then we are ready to go. So it's 0.19.2, and so there's the version is shown in the website here, slightly older because I'm doing it in 2000 now. So to load the data, we're going to use the iris flower dataset, and this dataset is famous because it is used in the Hello World dataset in machine learning and statistics by pretty much everyone. So it's like a Hello World program. So what the dataset contains are 150 observations of iris flowers, and there are four columns of measurements of the flowers in centimeters. The fifth column is the species of the flower observed. Now, all the observed flowers belong to one of the three species. So, if you want to learn more about the average flower dataset, we can just go and search it in Google, and then we'll know about it. So, for now, we'll get started by importing the required libraries, and here are the required libraries. It's said in the step 2.1. So we'll just import pandas, and from pandas dot plotting dot no dot, it's space. I'll get rid of that. Plotting, import scatter underscore matrix. Now import matplotlib dot pyplot as plt. So now we can use the plt keyword instead of pyplot matplotlib dot pyplot. So I'll be just typing it here, and you can just copy and paste it, but the best way to go as a beginner is to just hand type all these things. I'm doing so. So from sklearn.matrix import confusion underscore matrix and accuracy underscore score. Now sklearn.linear model import logistic regressions. Okay. Now from sklearn the tree dot import decision tree classifier. So now from sklearn dot neighbors import k neighbors classifier. Sorry for that. For sklearn dot discriminant analysis import linear discriminant analysis. From sklearn dot naives underscore base import Gaussian NB. And finally, from sklearn.svm import svc. That is loading the dataset, and we can load the data directly from UIC machine learning repository, and the URL is given here. I'll just copy and paste the URL in case of any typos. I'll copy and paste the names as well in case of any typos, and we have the dataset pandas.read underscore csv URL names equals names. Let's summarize the dataset. Now we are going to take a look at the data at a few different ways. Now first we'll see the dimensions of the data, and secondly we'll just have a peek of the data itself, and third we'll see the statistical summary of all the attributes of the data, and finally we'll break down the data by class variable. Now let's do it. So we'll just first see the dimension of the data set. Now for the shape, print dataset dot shape. Okay, it says 150 comma 5, and that's 150 instances and 5 attributes. And we'll see the dataset head. For the statistical summary, we'll do dataset dot describe. And for class distribution, we'll do dataset.group by class.size. Class dot size. Okay. So it's iris, setosa, Vesinicia, Vesicola, 50, 50, 50, total of 150 data types. And for univariant plot, we start with some univariant plots, that is, plots of each individual variable. And given that the input variables are numeric, we can create box and whisker plot of each. So box and whisker plots are as follows: syntax error, keyword argument. So what does it look like? So I'll just copy and paste it to get rid of the typos, and it gives us the details. So we can plot it, plt.show, and here we have the similar clearer idea of the input attributes as described in the website here. Now let's just manage the windows, and we can also create the histogram of each of input variables to get an idea of the distribution. So I don't know why this is not working. Oh, now it works. Okay. Dataset dot adds list attribute has no attribute adds list. So what's it? It's HIST. I did something there. Now just plot and show. Okay, it's a histogram of the dataset. It looks like the input have Gaussian distribution. We'll have the multivariate plots, scatter underscore matrix dataset plt.slow. So that's the multivariate plots of the dataset. So let's look at the scatter plots of all pairs of attributes, and this can be helpful to spot structured relationship between input variables. Note the diagonal grouping of some pairs of attributes. They suggest a high correlation and predictable relationship. Now let's evaluate some algorithms. Now it's time to create some models of the data and estimate their accuracy on unseen data. We'll do by creating an array and adding the dataset values to the array. We'll define x as array, 0 is to 4, and then y array is 4. Now validation size will be 20% of the total dataset, and we'll give the seed 7. Now is to get rid of the is to avoid the typing errors, I'll just copying and pasting this. Now for test hardness, we'll give seed 7 and scoring equals to accuracy. Now we don't know how much algorithms would be good on this problem or what configurations to use. We get an idea from the plot that some of the classes are partially linearly separable in some dimensions. Now let's evaluate the 6 different algorithms. Previously we have imported all these algorithms for later use, and we are going to use it now. So this is a good mixture of simpler, linear, and non-linear algorithms. Let's build and evaluate our 5 models. Now spot check algorithms. So models equals empty list models.append lr to logistic regression models.append LDA to linear discriminant analysis, and modules.append is an error. It must be a typo error. So lots of typing error here. So I'll just copy and paste. So it's decision tree classifier. Then modules.append NB, Gaussian NB, modules.append SVM, SVC. Now to evaluate each module in turn, we give an empty list of results and empty list of names, and we'll do a for loop here. For name module in modules, kfold equals to module underscore selection dot kfold and splits equals 10, and random underscore state is equals to seed. So it's an indentation error. I'll just copy the whole block of code and paste it. Then okay, now it works. So I don't know what I was missing there, maybe because I was working on a terminal. Now it shows the output. So let's see which one is, let's guess which one is the best model. So here the KKN has 0.98333. We can also create a plot of the model evaluation results. Let's do it and let's compare the algorithms graphically. Let's name it algorithm comparisons. Ax dot fix at subplot and plot the box plot in results. Then give the names and plot dot show. So here is the plot, and they're squares at top of the range, and some of them are giving 100%, about 100% accuracy. So we have KNN, NB, and SVM highly accurate than others. We can make predictions on the validation data set that was the 20%. So here the KNN algorithm seems to be the most accurate one. So we'll be using the KNN model. So KNN equals naive classifier, KNN dot fit X train and Y train. Predictions. Print the accuracy score. Y validation prediction. I'm getting these typos. What am I missing here? So this I misspelled predictions. So it says 0.9. So the accuracy score was pretty impressive. Now let's do it Y validation. And let's print the confusion matrix. Y validation predictions. So here we have the matrix. And now finally printing the classification report. Y validation and predictions. We have the recall 1, 0.92, 0.82, and average we have 0.9, 0.9, 0.9, and support average of 30. So the output log are similar. Now, wrapping up, what this tutorial meant was you can do machine learning in Python. Work through the tutorial above. It will take up to 5 to 10 minutes maximum, but it took me more than that because this was my first. And who's watching this video, I guess nobody's the machine learning expert. We're just noobs and naives learning. So here we go. Let's wrap up. First project in Python, creating a machine learning model, and then we just did it.